Hey, welcome back to the bench. Hope you're all well. Good to see you again. Thanks for joining. Today on the bench I got a Harman Kardon AVR 230. This Harman Kardon I bought off a local Kijiji because it has a fault. And the fault is it just shuts off on its own at random, and no explanation why. But I bought it because I thought, well, two reasons really. One, because it was 20 bucks and you can't turn down a $20 Harman Kardon with remote and original manual. But not only that, but it has that fault, and I thought it would make a good video for troubleshooting on how do you go about one of these multi-channel receivers. It shuts down on its own. Is it going into protect mode? What is it doing? Like, why does it shut down? How do we fix it? All those things. So I thought it would be good. Make a good video. Why is this glued together? So it came with a couple papers here. How to wire it all up. How to wire it all up. Quick start. And full manual. I want to look at the specs in this thing. I don't even know what's this capable of. Oh, here we go. 65 watts per channel, 20 to 20 kilohertz. That's stereo mode average. 65 watts per channel. This thing's really heavy. It's got like a massive power transformer in it. Is this a 5-channel? Center channel, surround. Yeah, I think it's a 5-channel receiver. Not a very new one. It doesn't have all the nice HDMI inputs and all that. It's just got S-video, composite, and it has optical inputs for the audio. So, it's not that bad. Another problem I noticed, I was playing with this before, and the volume encoder, these have a known issue with the volume encoders. And if I go down, okay, it's actually working today. If I go up, it sometimes jumps and goes down instead of up and up instead of down. So it has that problem with the encoder, and that's a known issue with Harman Kardons. I think they have a bulletin out on it, and they will just tell you to replace the encoder with a new updated one. But we're going to go in and see if we can clean it or do something to bring it back without purchasing parts. Yeah, it seems to be working. I don't have any speakers hooked up right now. Oh, see, that's not working. It was not consistent there. It comes up and down. It went up, see? If I go fast. So I have a feeling it's just a dirty connections in there. As you turn the encoder, it's probably dirty connections. So that's what I'm guessing. You go all the way up to plus 10. See, it goes down and up and down and up. See? yeah, -7 now. So yeah, we'll fix that. But remote is filthy. I think I took the batteries out. Yes, I did. Okay. We'll have to clean this up. This thing's nasty. One owner unit. He bought it brand new, and they used it up until a point where it started doing the shut-off thing. And then they pulled it from service and replaced it and put it up on the market for sale. So here it is. And it's not shutting off for me. Usually it shuts off after a few minutes, but it won't do it. So maybe I'll just leave the camera on and wait till it goes. Okay, so I was just reading through the troubleshooting guide here. What it says for anything for protect mode. And it says here the symptom is no sound from any speaker, light from a power switch is red, and you can't see it now, but it is red. Let me see if I can turn off these lights. It is a very, very dim red, and you can see it shining through the power button here. That's shut off right now though. Now it's also talking about doing a memory reset, and this is something you would do if you suspect that maybe the memory's corrupt or something. It says to hold down the tone button for 3 seconds. 1, 2, 3, and it should come on. There it came on. It has reset. Okay, so we did a full reset on it. It's not going to make any difference in what the fault is here though. Alright, so the first step in troubleshooting an intermittent like this is trying to get it to actually act up and go into a fault mode. But this thing's trying to make a fool out of me right now, because here it's been on for almost half an hour now, and it's starting to warm up. I can start to feel some little bit of heat coming from the amplifiers, and yeah, it's not shutting off at all, so it's going to make a fool out of me. It's going to be nice and well behaved right now. So if we can get this to shut down, then you can start troubleshooting what's going on with it. If you can't get it to act up and shut down, then what you have to do is pretty much shotgun it and go in and start looking for reasons why it shuts down. You got cracked solder joints is probably your main one, or a faulty part. That could be like a faulty voltage regulator that goes off on random, or something like that. But typically you want it to shut down so that you have a hard fault that you can actually diagnose, and instead of just taking shots in the dark at it and hoping you got it fixed and not knowing for sure. So what causes an amplifier like this or a receiver like this to go into protect mode, usually in these multi-channel ones, is the DC offset on the outputs on the amplifiers. They have circuits that monitor the outputs of each amplifier, and if you have a DC offset that goes out of a range, a specific range, I don't know what it would be, maybe half a volt, or maybe it's 1 volt, or whatever they set as their parameters. If one of those amplifiers goes into a fault, a DC, like a hard fault, and starts dumping DC voltage out on the output terminals, the protect circuits are supposed to sense that, and if it goes over a certain threshold, it's supposed to sense that and shut the thing down. So typically you can turn it around and have a look at the back. Let's have a look at the back anyways. I haven't looked at the back yet. Oh my god, that thing is heavy. So what do we have here? Got a bunch of preamp outputs for power amplifiers, video inputs up here, all our analog inputs over here, direct in for the, how many amplifiers we got here? 1, 2, 3, 4, 5, 6. Yeah, 6 amplifiers. Component video, coaxial inputs, optical inputs, our tuner inputs, not much else, and then we have a couple courtesy outlets. This thing was built in September 2003, so it's got some dates, some seniority to it. It's 19 years old now. So we want to check if we have any DC offset on the output, and usually if an amplifier is starting to fail, you'll start to see a bit of DC appearing on the outputs, and then if it gets to a threshold, the amplifier shuts down. It could get to a low value and it could sit there, or it could bounce up and down, or it could float. So we're just going to go through and we're just going to check all of these outputs. I got 27 millivolts there, 50 millivolts there, 35, 38, 45, and 23. Now, none of those were really that bad. I think that's right around normal for what this amplifier is. So, just going to wait for it to go off. In the meantime, I'll just yank the cover off. It is starting to warm up, which is good. I was just checking my watt meter, and this thing's consuming 53 watts, which seems high on idle. Let me check if it says anything in the manual. So here it says in the manual 118 watts at idle, which is, I find that hard to believe, because that is a lot of power to be just wasting and dumping into the air for not doing anything. This thing's consuming actually 53 right now. That's more of a realistic number. Okay, while we're waiting for it to shut off on its own, let's pull it off and have a look inside. Come on. A massive power transformer. It's huge. And then we have a massive heatsink here. It's about a foot long, maybe 14 inches. Video boards. And then we have 6 amplifiers down in the bottom there on the main board. Just got to be careful because we do have 120 volts here on this board, I believe, and probably some other ones here too. There is typically a voltage regulator board here that is mounted to the heatsink, and it's got 3 devices attached, and typically this is what fails on these old Harman Kardons, is these little voltage regulator they produce a lot of heat, and that's why they mount them directly to the heatsink. With that, you get cracks on the solder joints. I was giving a wiggle here and I'm not seeing anything. So you just carefully poke around with one hand in your pocket. You don't want to touch anything live. There's a power switch down under here that's got exposed wires. That's the hard power switch, and then there's a soft power switch in the same location. So you got to make sure you know which one's which. I'm not getting any response to. Usually if you have crock solders, if you tap around, you can get it to shut off or go into fault. I'm not seeing anything going wrong here. That is a huge transformer. Some serious power coming out of that thing. Okay, well, it's not going to misbehave for us, so what are we going to do? Let's have a look around at some of the solder connections. Okay, I've been poking and prodding this thing for quite a while now, and I can't seem to get it to shut down or go into fault. Now that tells me a number of things. probably is not a cold solder joint or cracked solder, because I am looking at some of these solder joints and they all look good. And I'm not seeing anything that's really standing out. Of course, I can't inspect the main board, and I can't inspect a lot of these boards because they're all installed. But you know, typically if you're going to tap one of these voltage regulators here, and these ones here, and if there's a cracked solder, it'll typically show up. But I'm not getting anything like that. Now, it could be something as a failing voltage regulator that maybe gets weak when it gets heated up, or maybe when it's cold. I don't know. But this thing's been going for a while now, and it's starting to warm up. I'm drawing about 50 watts from the outlet. You know, it's warm. It's about operating temperature, I'd say. But not seeing anything here. Now you go into each amplifier and you tap on the driver resistors, you can tap on the biasing resistor or transistor, driver transistors, any of these, you just tap on them. If there's a cracked solder, it'll reveal itself. But I'm not getting anything from anything over here in any of these amplifiers. Could be a bad capacitor somewhere too in the amplifiers. It's hard to say. This thing, it seems to put out a lot of heat, so maybe we got bad caps in this thing. Hoping not, because typically the capacitors down on the bottom here are the main board capacitors, and they'll still stay pretty cool. The ones up here could get cooked, but these ones aren't important. These are video. This is a video board here, and this board here is our input switching. All of our inputs, all the different analog inputs, is all switched by these chips. Interconnects, between board to board interconnects. I'm looked at them with a magnifying lens and not seeing any cracks. Could have something like a faulty chip, but it's not revealing itself here yet. So I'm just going to keep going, keep poking. There is a standby power supply down here for the remote and the syscon, and I'm playing here with the stick, and I'm not getting anything dying on me. So maybe I'll just let this go for a while, let it idle, and hopefully the fault will reveal itself. Alright, little update here. It's been probably 4 or 5 days now. This thing's been sitting on my bench. The first 3 days I had this thing running, probably a good 8 hours every day, and it never shut down. Finally on the 4th day it shut down, and then I've been trying to coax it to do it more and more. What my strategy is just let it sit turned on, like on the side here, and let it heat soak, and maybe that'll bring out the fault. I'm trying to determine if it's a temperature dependent thing, or if it's a cold dependent thing, or if it's something else. I've been monitoring. There's this thing has about 5 or 6 different power supplies, including the rail voltages for the amplifiers. So you have 3 supplies here. These are plus and minus 15 and 5 volts, plus 5 volts. There is a plus 5 volt supply there that runs off a little tiny transformer, and that one is alive as long as the power switch is pushed in. And that one supplies the CPU and the remote. There, it just shut off. Look at that. Poking my finger around in here. Let's turn it back on. Actually, you know what? I want to monitor something. This negative 15 volt supply has me suspicious. That's why I want to connect the meter up and monitor it. Let me see if I can get a look at this before I turn it back on. So where was I? Yeah. So I monitored these 3 power supplies, and I'm watching for the needle if there's any variation or wiggling or struggling to get voltage regulation. And I'm not seeing anything. Typically on these things, these voltage regulators die because of the heat and thermal cycling. Usually it's the negative 15 volt regulator that dies first. But the positive 15 volts can also go bad. And then the 5 volt regulator. And there's a 5 volt regulator in here as well. And I haven't monitored this one. But it's almost acting like it's losing a power supply voltage. And that's what causes it to shut down. Now, the reason I believe that is because I went in here and I set some of the parameters up and saved them. And then after it did a shutdown, these were all reset. So I'm wondering if there's a problem with the CPU, or maybe something that supplies the CPU, either a clock or a power supply. Or maybe something's going on this board that I'm not seeing, because I haven't had this apart yet. There could be a capacitor that took a dump all over the board and is shorting things out. I don't know. That's part of the mystery here. So I know I'm going to have some bad caps in here somewhere, down by that little tiny backup power supply and on this little regulator board. Typically those caps go bad first, and then there's caps in the power amplifiers that get cooked as well. So I haven't tested any capacitors yet, so I don't know what the state of them is, but I expect them to find some bad ones. And then I want to check capacitors on the front panel board. So that's where I'm at right now. Another thing I'm doing here is I'm monitoring the speaker outputs with my meter, just to see if there's any floating DC that's coming or going. But everything looks pretty stable. That's why I don't suspect it's an amplifier that's causing a shutdown. And I believe, I'm not sure, I have to check the manual, but I believe if there is an amplifier problem and it goes into protect, I think it says protect on the front. It doesn't just shut off, it goes into a protect state, and it displays that. I might have to go into the manual and check that out to make sure I'm 100% correct on that one. But all of these channels seem to be outputting maybe, let's see here, we're on the 1 volt scale, probably 15, 20 millivolts. This one's got about 25 millivolts, maybe closer to 30, 20, 20, about 25, and this one's at about 15. So they're all pretty stable and they're all rock steady. I haven't been seeing anything jumping around here, but of course it's not shutting down at the moment, so just keep monitoring. Okay, at this point I'm at a loss of what's causing this thing to shut down. So what I'm going to do now is I'm going to disassemble it. I'm going to remove the back panel. I'm going to remove these boards to get at the main board. Probably take the main board right out so I can service it, inspect the bottom for cracked solders, inspect all the capacitors, and I'm going to change any that are bad. That goes where the power supply, the main board, any other auxiliary power supplies that have capacitors. And then I'll probably end up taking the front panel apart just to inspect it, because yeah, it could be a leaking capacitor, but I don't really think so, because there's so many capacitors in this thing and I don't see any of them leaking. Usually if you get, 1 or 2 starting somewhere, you're bound to get them everywhere else, and they're all the same brand, it seems. So I'm going to do that, and then I'll report back what I find. Okay, let's deal with this rotary encoder. So I've pulled the knobs off, the 4 knobs, and I removed a bunch of screws here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10 screws, and unit pops out. And here's our rotary encoder. Looks like it's held in by 3 connections and 2 anchors, so that should be fairly easy. We'll just pull that out. What I'm going to use is solder wick, I think. So let's just get some flux on here. And then we can wick the solder. Let's cut this. Okay. Let's try this. All right. It should be okay. I should be able to pull it off. That's loose. There we go. Okay, put the solder cleaner off. Okay. Let me reposition the camera and we'll see what we can do for this thing. Okay, I've never opened one of these before, but it's pretty simple. It's just got 4 tangs, so let's just lift these up. And as soon as you get the last one, it falls apart on you, typically. Now, ooh, that one came easy. Now, Harman Kardon has a service bulletin on these rotary encoders, and they know there's a fault because they made a change halfway through production on most models. But yeah, there's the contacts. And they put out a bulletin about replacing them because of his known fault. It's got a little O-ring there. Keep the grease in. So with the bulletin, all the service centers do is they come in, they'll just replace this rotary encoder, but it's just a switch, right? And it's got like a few contacts. Let's see here, there's 3 contacts here on the bottom and 1 on top, and they coincide with this wheel, which is encoded with areas where there's metal and there's no metal, so it makes contact, doesn't make contact. So as you turn it, each click. Now if you just work the knob back and forth 100 times, it's going to wake up and start working again. I think it's just this old grease is really causing a problem. So let's clean off some of this old grease. Just wipe it. It's really sticky too. Look at it, it's kind of dirty. Let's see if we can get this old grease off. See, it's dirty. And I'm assuming this is all silver plated too, just for conductivity and contact resistance. So we got that. I guess the Q-tip is not ideal. I'm getting fuzz on everything because it's sticky. I have to make sure I get rid of all the fuzz before I reassemble. Okay, so let's just get this. Yeah, it's a sticky grease, that's for sure. Let's get some deoxit. Now, like I said, I've never worked on one of these switches before, so I don't know if deoxit is the magic bullet or not. It might be. It might not be the magic bullet. It might be something that. You know what? Let's have a good look at this before we put it together. Yeah, I can see it's silver plated and it's got wear. There is wear on all the surfaces where it makes contact with the with these contacts. These contacts look good, except they got fuzz all over them. I can clean these off. Still have fuzz. Okay, this one here looks okay. I think I'm going to give it a clean with some contact cleaner first before I reassemble. And I'm just going to use this stuff. It is picking something up. Okay, let's have another look. I don't think it's going to get any better than that. Okay, let's give it some of this. I want to get it on the outside too, because this is also part of the switch, the outside contacts. It's got a good feel to it. I think I still have fuzz here. Okay, I'm going to put this back together. I'm not going to touch the grease in here because it's part of the feel actually to have that sticky grease. Let's put this back together. Okay, and how did this go? Symmetrical? No, it's not. Okay, goes like this. All right. Crimp this all back together. A nice feel to it. I think that's going to work good now. Okay, so giving the back side of this board a good inspection, I did find some cracked solders on some of these connectors. And let's have a look here. These ones here, they look okay. I might just resolder these ones. These ones are cracked. There's some definitely cracked ones. Not all of them, but there's a fair number of them. There's probably, let's say 1, 2, 3, 4, 5, 6, 7 or so there. And there's some over here. I don't know. Those ones look good. Everything looks good. Looks good, looks good. Okay. So let's solder this up. Was this the cause of our issue? I don't think so. Could be. I don't know. But I didn't think the fault was a cracked solder, only because when I tapped around and banged on things, it didn't respond. So let's get my hang on here, I gotta get things untangled. Okay, here we go. So I'm just going to go through and do them all. It's hard to see here. I also went through the main board with the power amplifiers. Didn't find any cracks there whatsoever. Everything, the soldering all looked good. This is pretty much the only spot where I found a few cracks. Okay. The top one was cracked. You can have the classic sign of a crack is the, well, what the crack looks like. It looks like a ring around the joint, and as the crack progresses, the ring gets more pronounced and more visible. But if you look with a magnifier, you see that ring around the pin in the joint. You know it's starting to crack, so it's probably a good time to pull the iron out and redo it. Okay, so that's it for that one. I think I did this one already. Another thing I'm going to do is clean this board. There's some stuff here on around these chips. Doesn't look very good. I don't know if you can see that. Looks like somebody didn't clean the flux off or something. I don't know what that is, but I'll clean that off. I did find cracks here on the vacuum fluorescent display. You can see it here. I resoldered this. These three were cracked, and these three were cracked, so I just blobbed a bunch on top. Some of these were cracked. This is for the vacuum fluorescent display as well. And on this side as well, I resoldered these. I didn't see any problems with the vacuum fluorescent display. It seemed to be working, but you never know. Let me do some of these as well. I think it wouldn't hurt if I did some of these. Okay, I think I'll leave that for now. Everything else is done. Except one last step. One last step before we assemble is to clean the vacuum fluorescent display and the window, the inside window. You can see it leaves dust in here is really bad, so you got to get some glass cleaner, a little bit on a rag, and we're going to go in here and clean this. The reason it attracts the dust is because there's a little bit of high voltage on the tube, and that anytime you get high voltage, you'll attract dust. You see there's a little film on here. You can get this film off. And then when we're done, it won't look so foggy inside on the display. Clean the glass tube itself. You can see it's picking up a lot of dirt. And then dry it. Give it a little inspection so we can see. Looks good. Don't see any streaks on it. Any fogging. Okay, last thing we need to do is, and before we assemble, we just get some duster. This is just air in a can. Blow all the dust out of here. Put it back together. Alright, so I can assemble this. This can go back in the machine. I got the other boards done, so I'll bring you back and I'll show you what else I've done. Okay, let's give me a rundown of what I've done here. This is the main board. I've checked over all the capacitors on these little bias boards. I only replaced one. There was only one that seemed like it was out of spec, out of tolerance, so I changed it. And the other ones I checked, pulled them out and checked them, they're good. I also pulled each one of these little bias boards out and checked the solder connections on the bottom side, resoldered them, made sure there was no cracks there so that the biasing's all good, and then reassembled. I also checked all of these capacitors here, these 220s at 63 volts. Now they're starting to check a little weak from the heat, but they're still good, doing good. And then I also checked all of these 12 transistors, all the joints. So all the joints and everything on this is good. Didn't find any faults within the amplifiers that worth mentioning. Okay, now this little power supply here, that's a different story. This thing, there's 4 capacitors around this linear regulator. This is a 5-volt linear regulator, and they were all failed, and they failed to meet minimum spec, so I pulled them all out, replaced them. I also, just for preventative measures, I replaced the 5-volt regulator with a different one, or a new one, and I added a little bit of heat sinking to it. This power supply here is always on when the unit's plugged in and the main power switch is turned on. So this always supplies power for the CPU and the processor. And I have a feeling it supplies power for the system control when the unit's on as well. So I wanted to make sure this is good. So 4 new capacitors and 1 new regulator. And then there's this power supply board here. There's 3 regulators, plus or minus 15 volts and 5 volts. I replaced 4 capacitors in this because these top 4 were getting cooked. Is it 4 or 5? I think it's just 4. So I replaced those 4. And everything else I've done is just visual cleaning, maybe a touch up on a solder joint here and there. I didn't find any cracked solders. Everything looked good. So pretty much everything else is untouched on this. So that can go back in. Actually, it goes like this. Now, the front panel, I think you were aware that I removed and cleaned the rotary encoder. I resoldered some cracked joints along this connector. They weren't serious yet, but they were starting to crack. Did not replace any caps on this assembly, but I did clean the back of the board because there was some flux residue, and put it all back together. So that can go back in. Scratch up the front. Now the front, or this panel, this little board here is a interconnect between the main board and a few others. Inspected, there's no cracks, didn't do anything to this board at all, left it alone. This little board here is sitting on the one side of the transformer. This is a little power supply board, and I believe this supplies the higher voltage for the vacuum fluorescent display. And there was one dead cap here in the middle, and I replaced it. The other one's tested fine. No crack solders. Going to put it back on. This board here is a digital input board. Didn't do anything to it. Tuner, nothing done to it. Video board, just basically inspected it and resoldered these two regulators. Everything else is untouched. Now this board here is the audio input board. It has all the audio inputs for all the different CD and video inputs, and then it's got a composite something going on here. Now this is in kind of two parts, this board. This part here is all audio switching, like this is your switches for the inputs, and I didn't touch anything on here, everything looks fine. This side of the board here is a digital audio converter. I'm pretty sure it is, because the digital board plugs in the side here like this, and you have all the digital inputs and they all come in here and it converts it to audio. Now there was a little power supply here, and this little power supply, all these 5 dead caps here. So I replaced these 5 dead caps, and I think this just powers this crystal. It's probably a DAC. So that's good. Everything else was fine. No crack solders. This is a plated through board, so you typically won't find crack solders on those. So everything has been gone through. Time to reassemble and do some testing. All right, we're back together again. It's all good to see. Don't let a repair like this intimidate you. You know, pulling the back panel off one of these, because you have to pull the back panel off to get all the circuits out. It's really not that bad. It's just a number of screws, and then it takes a little bit of time to get these 20 or 30 screws out, and then once that, it all comes apart really easy. These are designed really well to be repaired and serviced. It's not that hard, not that difficult. So don't, like I said, don't let it intimidate you. But you do have to really pull it all apart. This thing's 20 years old now, 2003, so 19-year-old receiver. There's bound to be crack joints, there's bound to be bad capacitors, so you pretty much have to tear it all apart to get a good look at it, what's going on inside, and repair it. So here's what I've changed. 15 electrolytics. Probably half of these are dead, and the rest of them are dying. And then one voltage regulator. I changed this purely out of speculation that this is what the problem is with this shutting down. I think I just might connect this up in the breadboard here and test this out to see how stable it is, and if it has an internal fault, it's working, but how well does it work, I don't know. So all back together. Yeah, I think I explained all the areas I focused on. The power supply under there, power supply here, and a few other power supplies. There's one here on the audio board. I replaced some caps, did some work on the optical, the rotary encoder for the volume knob, and a few other things. So let's turn this thing around, hook it up to some load, and try it out and see. I'm kind of curious what kind of power output this thing has. I think it said in the manual it's 55 or 60 watts a channel times 6. So let's see what it can do. Alright, so I'm all wired in to do a power test, but I must have screwed something up royally because I have no button functions whatsoever on the front. But I can see the volume works brilliant. It goes the direction you turn it. It's supposed to, the way it's supposed to. It doesn't do any weird jumping up and down. So it's all good. Oh, and it just shut off. So there's definitely still a problem in here. And I'm beginning to suspect it's the front panel. Even the power button doesn't respond. And if it does, it's really intermittent. I got the remote here working. The remote's really dirty though. Turn it on. Turn on. It was working. Yeah, we got a problem with the either the power supply or something going on in the front panel with the Syscon. It was turning on and working with remote. Here we go. Turning it off. This remote needs a clean too. Yeah, even the remote's not functioning. Let's try setting the input source. Absolutely nothing. Okay, back to the drawing board, take it apart. Okay, I think I found the problem. Dumbass forgot to plug in one connector. There's two boards here. There's the main board that has the CPUs and the display unit, and on the underside there's another board that has all the buttons and switching. But that doesn't explain why the power button doesn't work, because I tested continuity of the switch. Switch is working, and it's plugged in here, and that signal is getting in onto this board. It must have something to do with, I don't know, it's sending the signal across. Let's get this fixed up. You gotta appreciate that when you do a lot of disassembly and assembly, sometimes you forget a connector, but whatever. Let's take that off. Nothing but time, right? Okay, we got one more up here. Let's take this out. Okay, I think I should be able to remove this. If I can get my... There we go. Yes, there it is, see? Let's look at... Let's try flipping this over. What's the problem with this? Okay. Yeah, but we still had a shutdown problem. It shut down on us the last time I had the camera running. So what is that that's shutting down? Let's see if we can figure something out here. Another thing I forgot to mention, you can see this green thing here. This is a nickel metal hydrate, sorry, battery, 3.6 volts. And I remember measuring it, and let's see what it measures. This battery measures out at 2.5. This battery's dead. Just wondering if I should remove that and replace it with a lithium coin cell or something that will keep that alive. I think I'll do that. I'll remove this cell. I don't think that would be the problem, the cause of the unit shutting down though. This is rechargeable battery, and when the power is on, this battery should be receiving a charge current, probably in the order of 10, 15, 20 milliamps, something like that, to keep it charged. This is just for memory retention though, for, you know, settings and backup. That's why when the power went out, I lost all my settings. So that would be the reason behind that. That would this battery. But this wouldn't be the cause of it shutting down. The cause of it shutting down could be getting some stray signals in here. That's the thing. Either that or there's a bridge somewhere that's causing a low resistance. This seems... I'm just wondering how they have this wired here. They have a button matrix. Sometimes they have resistors, dropping resistors, so on a string. So like if you press one button, it's 16K. If you push another button, it's 20K. Push another button, it's 25K. So that's how they do it sometimes. And then the chip senses the resistance, but I don't see that here. I just see it as a matrix. I'm just wondering how they do that. Anyways, this was a problem with the buttons not working, so we got it plugged back in. Let's maybe connect it back up and see if we can get some life out of this thing. And then I'll do a test to see if it's going to shut down on its own anymore. Okay, I got my iron warmed up. Let's pull this battery out. Yeah, it's starting to leak. It's a 40 milliamp hours nickel metal hydrate. All right, I think I'm onto something here. This circuit here this is the battery. This is the backup battery. This is 3.6 volts, a nickel metal hydrate, and this is ground positive. This here is VDD. This is line SNB3, and it's going through a 10 ohm resistor and a blocking diode. And I think this is what keeps this battery charged. Now, this chip here is a voltage watchdog. It senses, it's a 1.5 volt reset, and it triggers on if the voltage drops below 1.5 volts. It triggers and does a reset in. Reset in goes right up to this chip here, reset in. And there's two chips like this. There's a 1.5 volt and there's a 2.8 volt. It's on the other side of the schematic here. Now I have a feeling this battery is flat and dead, and what it's doing is it's actually dragging this line down to at least, when it drags it down to at least 1.5 volts, it triggers this and shuts down. That's what the intention of this circuit is, I think. And as long as this battery is above 1.5 volts and charged, this circuit works and everything's fine. So I don't understand why they would have that here. I guess it's just a bit of protection. Let's see what else here. VDD. We got two blocking diodes here. There's a capacitor here, 47 and 1066.3 volts. That's on the VDD line to ground. So I think that's what's going on here. More capacitors here, 220 at 10 volts, 10 at 35 volts. So what I could do is I could attach a line to pin 1, and actually, you know what? I should attach a line to pin 2, and I could monitor this voltage. And now that I removed the battery, it'll probably never shut off. That's what I'm thinking now. If I put the battery back in temporary, I could test this on line 2 to see if it's triggering this thing to shut off. Let me tack the battery back in. I can do that on the back side of the board, easy. And let me tack a line to pin 2, and I can monitor that voltage, and then we'll see what's going on with this shutdown. Okay, back together again. I got a voltmeter connected up to pin 2 of that voltage sense chip. So we're going to sense the voltage Right now there's zero power, the main power switch turned off. And what we're reading right now, 1.15 volts, that's the voltage of the backup battery. So let's turn this main power on, the standby power. We'll see, this goes up to 3 volts, 3.1, should stop around 3.2. That backup battery is not holding a charge at all. Let me shut this off for a sec. And it should drop right back down again. Okay, let's turn this on. And let's see, let's get mode. Let's get rid of this surround sound. These buttons are really dirty. Source. CD, okay. See, why does it do that? Surround off. Alright, you know what? I think now we're ready to do a power test. Seems like everything's working. We got 3.3 volts on our backup battery. Let's shut this off. Let me rig up the my test load and we'll get a signal fed in. We'll do a power test. Alright, we're all wired in for a power test. Turn this on, main power. Turn on the receiver and it shut off. Turn it on again. I hope that was me doing that, not the receiver. Okay, let's connect it to input CD. Let's turn it up till we get clipping. There's clipping there. So I have a choice of clipping or not clipping. Okay. So what do we get? We're getting 22.86 volts RMS. Let's see if we can tweak this a little more. Right about there, I think. 23.67 volts RMS. Let this go for a while and cook. Huge, massive heatsink. So yes, I saw this in the specifications. Stereo mode, continuous average power, 65 watts per channel, 20 to 20K. That's at 0.07% THD, both channels. And then 6 channel surround, they're specifying 50 watts per channel for all 6 channels. So that's what, 300 total. That would be your maximum. Now I have a solution for the backup battery problem. I have one of these little holders, these AAA holders. And what I can do is I have AAA nickel metal hydrate batteries. I'll just pop 3 in here and I'll tack this into the circuit and mount it somewhere on a piece of sticky tape or Velcro, and I'll attach it here, probably on the side of the heatsink maybe, or down below somewhere where it won't rattle around, and can get at it, and that'll be my solution. Don't need to really replace the battery, but it is nice to have that memory retention function. If that is actually the problem, why it's just shutting down, I'm not 100% convinced yet. We're getting 3.3 volts on the on that trigger chip. So I'm just going to let this cook for a while, and then I'll come back and continue on. Okay, so I think this has been going on for 12 minutes now at full power, and I think it's proved its point. This is starting to get warm, but this is a massive heatsink. This side is quite a bit warmer than this side, which is understandable. My load is quite hot, and I think it's good. We can turn this down. Now, one thing I'm noticing here is this voltmeter is quite concerning. I'm watching the voltage. It would crash down to about 2 volts, and then it would climb back up again, and then it would crash down. I think this is what's going on with it shutting down. I just wanted to monitor this some more, because if this thing shuts off, probably what I'll do is I'll let the camera run, and if it catches the event, I can show it on the video. But right now it's up around 3 volts and it's behaving, but then it'll crash down. I don't know if you saw it. Well, you haven't seen it because I cut it out. But like I said, I'll post the event so it can show up. All right, let's set up the bias for this amplifier before we carry on too far. Now this is out of the AVR 330. I just shut down again. Look at that. Turn it back on. This thing is just playing with my mind. So this is out of the AVR 330 manual. I couldn't find one for the AVR 230, but these are basically the same models, same power outputs. The only difference is the AVR 330 has 5 channels, where we have 6. Okay, so pretty much the same thing, same power output, same design. We're just going to use the same bias spec. So connected voltmeter across these connectors, and you'll see these connectors are down inside here. They're white, and they have 2 pins, and there's 1 for each channel. Okay, and then you're going to make your adjustment on these little bias boards. The bias board is attached to the heatsink, so it can thermally track the temperature of the amplifier, and then this is the adjustment for this channel. Now what we do is we want to adjust this to 26 millivolts approximately. They say plus minus 5%. I don't know. That's pretty touchy adjustment, but we'll get it. If you're lucky enough, you have a little adapter plug you can plug in there, and you don't have to hold your leads. You just plug it in and then connect your plug-in thing to your voltmeter, and then away you go. Just for the purpose of comparison, I checked the watt meter. This thing's been turned on and it's been warmed up, and the watt meter is saying it's drawing 50 watts from the outlet. Now you got to be careful here, because you have high voltage down here on this green board, and then you'll have high voltage down here on the switchboard. So don't be sticking your fingers in anywhere there. So got a voltmeter here. Get it into frame, and let's do this. So I'm just going to put my leads on the... Don't worry about shorting these out, because all you're doing is it's just across a resistor. And here, let's try and get this right. Looks like I got 10 millivolts. Okay, so let's adjust this. I can't even see here. I'm trying to work around a camera. Let's get down here with the screwdriver and adjust this back up to 25 or 26. It's going the wrong way. Got to turn it the other way. There we go, 26. Now 26 millivolts equates to about 48 milliamps idle current on each amplifier. And what is that? I'll explain that in a bit here. Let's get through these. This one's at 8. Let's turn this one up. Next one. Now you can't see what I'm doing here. There's boards in the way. This amplifier is completely shut off. No, this one's at 28. I'm going to turn this one down a little. Okay, next one. Where's the... It's hard to see. I'm going to turn it up a little. These have probably never been adjusted since... Oh! There's hot resistors there. Get this out of the way. It's definitely much easier if you had the plug, then you can just plug it in to the socket there, and then you wouldn't have to hold the probes. But we'll get it. We'll get through this. Is it 13? Okay. Where am I? Which one am I on here? Okay. The last one. 23. Turn it up a little bit. Okay. I'm going to let that cook and idle for a bit, and then I'll go back and check them all. And if any of them drifted too far, I'll readjust it. Now what has to happen is the amplifier has to, the temperature has to stabilize on the amplifier. That's what I'm waiting for. Because some of these are turned up, some of them I turned down. So the ones I turned down will be generating less heat. The ones I turned up will generate more heat. And then the heat sink will need to stabilize and temperature stabilize across all of them. And then once that happens, I can go through and check them once more. Okay, so the watt meter now says 55 watts. And that's the idle power consumption of this receiver. Still have to go through and wait. So after doing the battery replacement, I brought it out here to do some listening tests, and now it's really misbehaving. It won't even turn on. And when it does, it immediately shuts off again. Come on, baby. You can do it. Yeah, and it's always losing the settings. It always reverts back to this FM 87.5, even though I'm using it on CD. But yeah, that's what it is. It is what it is, I guess. Okay, here I am apart once again. This time I took this board out and I gave it a good scrutiny. I replaced a few caps just because they're borderline. These 1000 microfarad capacitors were reading like down at 800 and something, and they had double the ESR they should have, so I just replaced them both. And the 220 as well at 10 volt, it measured down around 180 microfarad, double or triple the ESR, so I put a new one in there. And the other capacitor is a 47 microfarad. This one didn't measure too bad, but I figured I'm in here, why not? Now these three caps here are disc capacitors. These are the ones that concern me the most. They are super drifty, and they're leaky. All three of them are leaky. They do have DC leakage. Is this the problem? I hope so. What I did is I replaced them with film caps. These ones, I was not impressed with the value. Super heavy drift with temperature, but they're just decoupling caps. It shouldn't really matter. But if they're leaky, if one is going leaky and drawing a lot of current, it can pull that line down. So that's why I opted just to replace them. These are cheap. I had them on hand, so I was going to replace them. I'm just trying to do process elimination here and see what I'm like. I can't find anything wrong here. There's some other capacitors here, these little tiny ceramic ones. I don't know if any of them are defective or not. There's that coil. But I'm going to put this back together and give it another test and see how I'm doing this time. Okay, so let me give you a little update what I found out here. I think I'm making some progress. I'm pretty sure I found the fault. Just not sure how I'm going to fix it. The problem is this little chip here. It's a supervisor chip, voltage supervisor, and it watches the voltage on this VDD rail. And when it drops below a certain point, what it does is it sets a reset pulse to the processor. Okay, now the reset pulse goes on this reset in line, and this is SN14. And I've followed this line everywhere around on the board, and it only goes to a number of locations. It only goes to this chip, the main processor chip, and it goes off board to a reset button that's on top of the power supply transformer. Now, the reason the receiver shuts down or refuses to turn on in some instances is because there's no voltage on this reset inline on SN14. So what I did is I replaced the battery. I told you that before. And I replaced some of these capacitors. And I told you that before as well. What I did today is I replaced this 12K resistor because it was suspect. And I thought maybe got a bad resistor, and because when I was monitoring the voltage on pin 2 of this chip, it was all over the place, all over the map. And when it fell below the threshold, the receiver would shut down, right? So I just changed this out of precaution, but I don't think there was anything wrong with it. I think the fault lies in this chip itself, and I'll show you why here. Let me pull up the data sheet for this chip. This is the type we have. It's a CMOS output, and it is supposed to pull up the output when the VDD is up high enough. When VDD drops below a threshold, which is set by this reference, it's supposed to ground the output. As of right now, I can't get any voltage through from pin 2 to pin 1, and that is what's keeping the receiver from turning on. Or if I lose that voltage, it's intermittent, it's flaky, and if I lose that voltage, it shuts down. So I'm pretty sure this chip is bad. I could probably order one of these similar chip, not identical, but similar chip and similar voltage. I can probably get one on DigiKey for about, well, less than $1. So I'm probably going to go that route and replace this chip. But for now, I have removed this chip and the receiver won't turn on at all. And that's because I don't have any way to pull up that reset in line. So what I'm thinking of doing is I'm thinking of just adding a pull-up resistor. I could do that, or I could just short between VDD and output, because there's already a 12K resistor here. That could be my pull-up resistor, and that pulls up right here. This battery I'm measuring about 4 volts, so that would be the 12K would be a good pull-up resistor. So if I short pin 1 and pin 2, the receiver should work normally. Just I won't have this feature of Watchdog over the voltage, the supervisor. So let me do that, and let's get this thing going again. Man, this thing's kicked my ass. Okay, so what I did is I reinstalled the chip, just out of curiosity. I reinstalled it, and it wouldn't work. This little three-legged bug here. And I'm looking at this with a magnifying, and it's got 18 on it, which tells me it's a 1.8 volt supervisor chip. So I'm going to order a 1.8 volt chip, and when it comes in I'm going to put it in. But in the meantime, what I did is I jumpered pin 1 to pin 2 to pull up that line, that reset line, like I was talking about, and it's all working now. So it works fine. I'll test it. I'll turn it on, let it sit for many hours, but I have a feeling this is the end of this one. I also checked by turning off the power. It's no longer losing its memory because the battery's been replaced, and it always comes back with the last settings and the memory's intact. So I'm going to call this one done. This was a hard one. It really threw me off. Typically on these, I made the assumption right at the start that it was just a bad voltage regulator. You know, it's probably just an easy fix. But no, it wasn't a bad voltage regulator. It was something more in depth than that. But what I'm going to do is I'm going to test drive this thing and make sure it continues working. It was either the supervisor chip or it was the main processor chip, and that's what I was afraid of. But it looks like it's working now, so that main processor chip is good. But typically when these things act up, it's usually a voltage regulator. You have a bad voltage in one of your power supplies, and that's typically what you look for and go after first. But in this case, not so. So anyways, I'm going to wrap it up there. I'm going to finish this one off. It's a nice receiver. I really like it. Other than, you know, it's got the surround sound, which is kind of useless features for me. But it is a nice unit, and the little bit I did listen to it when I had it on my test bench it sounds great. So I might listen to this a little bit more, and yeah, it's a nice one. So anyways, thanks for watching, and we'll see you on the next one. Take care. Okay, here it is. It's a couple weeks later. I just want to do a follow-up on this because I think I want to put this one to rest. Now, I had hooked this up on my listening bench for probably 2 weeks, and I listened to it for the first 3 days. Wasn't overly impressed with the sound quality of this receiver. It's okay, but it's not spectacular like some of the other Harman Kardons before it. It's just average. But I had no problems with it for those first 3 days, and then all of a sudden it started acting up again and shutting down. So what that tells me is it has a problem in the microcontroller, and I don't believe it's repairable unless I replace that microcontroller. Now, would I repair something like this with a microcontroller if I have to get a parts unit or source the part. I don't know where I would get it from, but I think this is a no fix. So as it is right now, there's no fix for this. I'm just going to scrap this. It's going to be scrapped out for parts. Like I said, it's nothing spectacular in the sound department. It's got some nice features. It's got the remote, and you know, I'm pleased with the repair I did on the rotary encoder, but you know, you can't get them all, and this one is, sadly, it's not going to make it. So I'm going to end this here, and thanks for sticking through and watching to the end, and I appreciate my viewers and their patience. Sometimes we can't always fix it. Sometimes we just have to throw the towel in and give up. All right, thanks for watching. Take care, and we'll see you on the next one.